My name is Eric Sammer. I'm the CEO here. I'm the founder of Decodable. Just a little bit of context. Decodable has largely been in stealth, since we were founded. Um, we're just a little over a year old, and today I have Sharon and John with me. Sharon joined right away as one of our founding engineers. I'm going to sort of take us through sort of an overview, and then I'll hand it over to Sharon to talk about more details and even show all of you a demo. Just to sort of get rolling, I think it's worth thinking about the state of stream processing, in the large. All of you are sort of really well versed in this, so I'm not going to sort of try and teach you about stream processing, but I think it makes sense to talk about some of the good stuff and some of the not so good stuff. So, there's a bunch of stuff that actually works really well. At least for some definition of really well, and when I say stream processing today, I'm mostly talking about systems like Flink, K-streams, and Spark streaming, maybe to a lesser extent. We spend an awful lot of time with Flink. I know the team at Netflix, does quite a bit with Flink as well. But I mean, the performance elements, latency, throughput, maybe not machine efficiency, that's a different discussion. Scalability of things like Flink in terms of just like the volume of data that it can deal with and those kinds of things. And especially the correctness of Flink, with its checkpointing and save pointing systems, and its recovery semantics and stuff like that. These are things that, like, for the most part, in modulo, a whole bunch of configuration and tuning actually work pretty well. Flink itself is extremely flexible in sort of all the crazy ways. It's got like 4 deployment modes and 3 APIs, and it's got every conceivable feature you could want, to kind of allow you to build, whatever kind of data platform you really need to build. And I think over time, the programming model for streaming in general between Apache Beam and Flink and GCP data flow and like all these other kinds of things have settled on a kind of like a fluent data flow style programming model that, for the most part, most people can learn pretty quickly, with some tutorials and stuff like that. So like, this is not the place we see people struggle with these kinds of systems. So the question, that we ask is, okay, so if all of that is true, why are most people that are doing continuous processing on data still doing it in batch? And if this is all true, why can't the average application or data or ML engineer build streaming data pipelines on their own? And with all the love in the world to the people on this call, like, we all love this stuff, for the most part, on most days, why do teams like us actually even need to exist? If you look at the database world, you don't necessarily need to have a PhD in, concurrency systems and durability, things like MVCC and sort of isolation levels and all these other kinds of things to use something like Postgres, or any of the modern sort of MPP systems, Snowflake and BigQuery and all these other kinds of things. Why isn't streaming the default way that we process data, especially in all of these situations that are sort of naturally streaming? We see all of these cases where people are still doing tons and tons and tons of batch processing, and you hear people say things like, well, batch is easier, or it's simpler and we start there, and then if we really need to, we move to streaming and all these other kinds of things, rather than people being able to just build what they want to build from the beginning. And so this is where we get into like the less good parts of the streaming ecosystem today. In almost every way, stream processing systems are like weird and complicated, at least for the majority of engineers. If you think about the typical Java programmer, the typical Python programmer, or JavaScript programmer, they are really, really, really not interested in learning the ins and outs of like messaging guarantees, distributed checkpointing systems, and tuning RocksDB, and like all of these other sort of gory details that I think we spend a whole lot of time on. Foremost, the concepts, semantics, and behaviors of streaming systems are at best not well understood by most people, and at worst just super weird and complicated. I think, we talk to people about watermarks and late arriving data, and again, like all of these kinds of things. Job recovery and the semantics around job recovery are just like super, super complicated. And the weird part about all of it is that it's not like those problems don't kind of still exist in the batch world. Like, you can still have late arriving data in the batch world, but for some reason, it's easier to sort of think about the idea of like my batch runs and then data shows up, and that potentially means I need to fault a bunch of downstream data sets that I've built. When you actually like think about that, it's not that that is actually in any sort of meaningful way easier than what we deal with on the streaming side, but for some reason, it's this big sort of thing. I think the developer experience around streaming systems, there's no nice way to say this. It just stinks. Like, it's just not fun. For anybody building things, like in a lot of cases, they're mucking around with like class loaders, and is it the system class path first or the user class path first, and like all these kinds of things. They're building Docker containers to like build a single job and stuff like that. They have to worry about dependency chains and which part of their code is serialized and deserialized in different ways, and how they pass config parameters. The patterns are just not well understood. I think, in terms of like, what do you do in one Flink job? And when do you string together a bunch of different Flink jobs? And like, what are the trade-offs? Whereas I think in the batch world, those kinds of things tend to be at least better understood. And I don't know if that's necessarily because there's like less flexibility, or just because people have been doing it longer, but for whatever reason, people are used to dealing with these problems in the batch world. The configuration, deployment, and operations, like, again, I probably don't need to tell all of you, you all are pretty sophisticated, in sort of like your adoption of things like Flink, but like, it is no small feat to get Flink running. You basically need to be like a Kubernetes expert, or, God help us, a Yarn expert or something like that. You really, really, really need to know the ins and outs of like configuration and resource allocation, and all these other kinds of things. And again, if you compare it against how people build batch jobs, with things like Apache Airflow and dbt and Snowflake and those kinds of things, or BigQuery, we are asking like a substantially greater amount from data engineers, from ML engineers, from application engineers, in when they engage with streaming systems. The operational component of this, I think, is especially interesting because streaming jobs, again, all of you know this, but have this sort of different operational characteristics because they are more like services than jobs. They are constantly running. They sort of have like different properties to them, and require, in a lot of ways, more care and feeding. They're less tolerant of, network partitions and sort of all these other kinds of things, just because of sort of how they run. So our assertion is that it doesn't actually need to be this way. I think for a long time we've looked at this and we've said, streaming's just hard, and we sort of like accept that. I don't necessarily think that that needs to be true. And so that's kind of where Decodable came from. And I won't tell you, I won't, I mean, we're happy to show you a demo and stuff like that. I'm not going to try and sell you on Decodable. I'm more just want to kind of share like the decisions that we made, and why we made them, and why we think they're interesting. So, our core goal here is to make it possible for any application engineer, data engineer, ML engineer to build streaming pipelines with the knowledge they already have, without sort of learning the ins and outs of like what everybody on this call or in this presentation, without all of the knowledge and experience all of you have. And I think that this means that, you know, more people can be self-service, more people can sort of get up and running. And like, yes, there will always be this long tail of super complicated use cases, especially in the most sophisticated cases, which, you know, I think Netflix is probably one of them. But, you know, I really think that, you know, there's an 80% of what people do with streaming systems that is parse, filter, transform, light aggregation, and like those kinds of things that doesn't get into the gory details. And I think in order to make this happen, I think, you know, anybody in the right mind who would sort of build these kinds of systems today would do it as a cloud service. For better or worse, and like I'm sort of like a known SQL hater, but I'm gonna say it anyway, you know, everybody knows it, you know, and for better or worse, people understand the semantics and the type systems and like the operators and even the function and syntax of SQL. And so there's a high value in sort of meeting engineers where they are on this. More than anything, again, clear, simple, intuitive concepts, semantics, and behaviors. Like in other words, these things have to like do what engineers expect them to do. You know, they need to be sort of like the kinds of things that you can reason around, which I'm not totally sure that they are today. I think we as engineers sometimes undervalue the developer experience. You know, I think we've all probably seen cases of maybe not the best technology getting really widely adopted because it's just so easy to do and just so easy to use and for people to pick up. I think that we do ourselves a disservice by sort of ignoring that. And so like for Decodable, we sort of place that front and center. And then finally, I think like we have to kind of up level away from stream processing and messaging, which to me are building blocks, and focus more on data engineering and pipelines. And I do think that those are different things. I think data engineering is really more about higher order concepts and less about messaging semantics and checkpointing systems and those kinds of things. I think the latter is really for systems builders or, you know, infrastructure teams, whereas data engineering should be the kind of thing, just like when someone uses Postgres, it should be accessible. It should be a thing that anybody can do. And with that, I'm going to hand it over to Sharon, who's going to take us through like a bunch of the technology and the architecture and the demo and all that other kind of stuff.
Thanks, Sammer. So for my part, I want to dive into a little bit detail on what we've built so far. So this is a diagram of our platform. At very early of Decodable, we found that it's very important to have a good conceptual model so we can talk to users with less experience. So not engineers like you guys here, but you know, the end users who just want to build pipelines. At a high level, we view it as we get all the data from external systems into Decodable. Decodable does all the data processing, and a key point here is we don't plan to store the customer data for long-term usage. We just pump them out to external systems. So there are many names for this kind of model: data integration, ETL, and other names. We don't particularly subscribe to a name, but mostly focusing on the use cases here. On the two sides, the systems are pretty much the same thing: microservices, messaging systems, storage, and database. Those systems are integrated into the Decodable platform through connections. So connections are running instances of connectors, and they can be different types of connectors, as you can imagine. At the core part of the Decodable platform are pipelines. So pipelines do all the heavy lifting processing. Again, the same stuff like you'll know field extraction, filtering, data cleansing, masking, and some windowing and aggregations. Streams connect connections and pipelines by holding the records from connections and pipelines. And again, those records can be consumed by pipelines and connections. An easy way to think about it is it's a messaging queue that holds the records for processing. Here's a little bit more formal definition of those objects. I won't go into details. I just want to call out a few things. Connections are active objects. By active, I mean it has a state of whether it's running or it's not running. When it's running, the data is moving. When it's not running, obviously not. A connection can be a source or sink. This should be pretty straightforward. They either get the data into the system or out of the system. Streams are passive. They just hold the records. Also, each stream has a schema. So if connections or pipelines want to consume data or write records into a stream, the records must have compatible schema. Pipelines is where the SQL part comes into the picture. As Samuel mentioned, we decided to use SQL. So basically, we use SQL to express pipelines. So each pipeline is defined by a single query of a SQL statement. And it starts with something like insert into the destination stream, and the select clause will do all the data processing. And the from clause will specify where the input streams are. Also, we support joins and unions, so we can process multiple input streams, but there's always only one output stream by our design. Also, pipelines are active, so they can be running or not running. Okay, so I think the best way to show you is how we map the conceptual model into the user experience is through a demo. So, okay, so users interact with Decodable through, we have a UI tool, but basically here I'm gonna show you our CLI tool. Obviously the CLI is called Decodable. So the easiest way is to look at what you can do with a command. The normal stuff, like you can log in and config, we can talk about it if anyone is interested. But config basically allow you to manage some of the configurations. Particularly, we allow multiple accounts to exist. So you can have multiple Decodable accounts, and you can use the same tool on your laptop. So other than that, you can see connection, pipeline, stream here. There's no surprise, that's a mental model. So we can look at what we can do with them. So I have an alias for Decodable because I'm lazy. I'll just show you, for example, for connections, you can do the normal CRUD stuff, create, get, list, update. As I mentioned, connections are active objects, so there are also commands to activate a pipeline or deactivate a pipeline. As for stream, stream is passive, so you will not see the activate command. Similarly, for pipeline, there should also be deactivate. Pretty similar. We try to keep the model as consistent as possible. So when a user comes in, the first thing they would normally do is to create a connection. So in my system, again, we have those short alias for names because I'm lazy. So as you can see, in my system, I have a bunch of connections in the systems already. They can be source or sink. Different connectors exist. Here we have a REST connector, which basically accepts events in, we have a REST endpoint, and you can send events to that endpoint. We have Kafka connection. I can show you what this configuration look like. So use a get command with ID. Okay, cool. So this is the Kafka, the very, very basic Kafka configuration. Obviously, there are many more properties you can specify, but the simplest one is you need to specify where your Bootstrap servers are, the topic, the format of your data, and also the schema of your data. So we optimize our system for the first-time user experience. So we also have, as I mentioned, we have those data gen connections. So I'll just show you what it looks like. We actually have this connection provision for each new account. So when you create accounts, there's already a data gen connection. So for this one, it's basically, produce the Envoy proxy kind of raw logs. It just generates those like HTTP events kind of logs. And as I mentioned, connections are bind, needs to talk output for source connections. It needs to output to a stream. So as you can see here, this connection has is referencing a stream ID. So we can also look at the stream definition. It's pretty straightforward. You just have a schema. The schema has a field name, value, and a type of stream. Again, this is the same as the schema here because the connection produces a compatible schema to the stream. We can actually, at this point, when user creates a connection, the natural thing they will want to know is the connection working? So we want to make sure there's quick user feedback when they are working on with our system. One feature we come up with is called preview. So a preview basically is an ephemeral Flink job that takes in a SQL statement. You can see it has a temporary pipeline, and it runs the query, and it returns the result output to the console. So I'll show you. Again, PL means pipeline. I'm just lazy here. So the easiest way to know if the connection is producing data is by checking if there's anything in this stream. So I'll start with this simple SQL. It just selects everything from the stream. And behind the scene, we are doing a lot of like SQL parsing and planning, you all know. And our deployment also actually starts a Flink pod. Behind the scene, let me see if I can show you that. Yeah, so here on my right screen, I'm showing you like our actual deployment. We're using Kubernetes. So this is the data plane, one of the cells in our deployment, and it's called data plane. You can see we have a lot of running connections and pipelines. But you can see these pods that just started like 25 seconds ago. That's the preview job I'm running on the left side. Okay, cool. So the result came back already. Let me make it bigger. Yeah. So again, this is a JSON data with a field value and a raw string. For each event, it's a raw string of the HTTP event. a very, very common use case for people to work with such logs is to turn this into something more structural. For example, like to have a field that's called timestamp, the HTTP status field to be an integer so they can do further processing. So I prepared a SQL statement here. Okay, so we have a SQL here. This is just an example of like how people would do this, how would process their data. Again, this is a simple select from statement. Envoy row is the stream I just showed you. For this kind of, because field extraction is such a core part of Decodable, we provided the user-defined functions for easier field extraction. So in this case, the best way is to through a grok pattern matching. So this function basically operates on the value field, and it takes a grok pattern. The result of this function returns a map that has a name and a value. And then we can do further processing, like, for example, I'm making this timestamp actually a timestamp data type. We are casting the status into an integer, and I'm only choosing the method and path for this this field extraction. So again, I can quickly, if I'm a user, I want to see what the result of this SQL, so I can quickly run a preview of this SQL to see if this result is exactly what I expect. So while this is running, I also want to show you some of the other stuff we have. So like we said, we want people to be easily integrate our tools into their systems. So one thing we have is to output this, the output of our result into different format. So for example, I can get something and output to a YAML file. So this should be very, very familiar to anyone who played with kube control before. And similarly for JSON. This is just make it a lot easier when people want to use Decodable into their workflows and they have the structured data to work with. And we have this preview back. Oh, this one is super fast. Awesome. Yeah, so you can see like within 16 seconds, you already know the result of your preview. And now you can see the result of this SQL produce a very well-structured data. Again, we purposely only keep 10 records for preview because we don't want to run this preview for too long. The preview job will also automatically expire in 2 minutes, just to make sure we keep our resource consumption efficient. So you can see this is a for each record, you have a method, you have path, and the status is integer. Timestamp is a timestamp. It's not a string, but it is a timestamp. The next thing I want to show you is, so if I am a user, again, at this point, I'm very happy with the result of the SQL. So I actually want to make it a real pipeline and run it in production. So I actually already created that one. Yeah, the first one I showed you. You can see beyond all this metadata and the status of this pipeline, the SQL is exactly the same, except that now it also writes into another stream. So this insert into a different stream called Archie Envoy events. So this is basically the way we provide confidence to users when they are working with the system, and they can, when they activate this pipeline, they have enough confidence. The next thing I want to show you, let me check on my time. Okay, so let's see. The next thing I want to show you is the destination of this stream. We didn't talk about stream that much. So you can see the first stream. So this stream has again, the schema is not surprising because that's what we produced. The main thing I want to show here is this watermark field. Again, this should be very familiar by all of you. Watermark is at the core of event time processing. So this is just a way for how we expose the field to the user. So here it's basically essentially saying I'm using the timestamp field as event time processing, and I give it a 5-second window for late arriving events. With Watermark, you can easily do all those windowed aggregation. Again, super common for stream processing. And I can show you another preview that, oh, actually, let me show you the SQL. So one common thing you could do with the data, the parsed data, is you can start doing aggregations. For example, here, I want to do a windowed count. Again, here I specify the stream I want to operate on, and I put into a tumbling window, and the window size is 5 seconds. And in each window, we are doing the count on the status to know the success count, the user error count, and the server error count. This can be, we can see the result quickly by running another preview. Again, this takes some time. Did I show you all the pipeline? Okay, yeah. So for this pipeline, I'll come back to this. You can see we also report some of the metrics and the actual state, if there's any user errors. Again, those are super important to users to know when their pipeline is active, what's happening. So this is one way for us to provide user visibility into their systems. And this data is live, actually. So if I do another one, you should see a slight difference. Yeah, you can see this was like 596, and now this is 600. So we keep this data live, which is one feature we feel pretty happy about. Okay, so on the left side, you can see the result come back. It's about every 5 seconds, you will see a new record. And that's expected because that's the window size. And you can see all this error counts, success count, user error counts, all those things. So this, hopefully by now I give you an idea of how user interacts with the system. Again, this maps directly to our conceptual model. We have preview to help user quickly iterate on their pipeline building process. And after that, we provide the real-time metrics and status information to the user, so for user visibility. Yeah, so I showed you what we've built so far. Decodable is still young, it's been a year. While we are building the platform, we found there are a lot of things we need to do, which is a good problem to have. So this is just a short list. We still need tons of ecosystem integrations so we can get all types of data into the system and get the data out to other systems. We still feel there's big improvement on the user experience. For example, the CLI experience. We are also working on a UI for people who are who like to work with the UI graphic UI interface. There's also a lot of discussion about how we manage the objects, how we do the version management. We want to provide workflow support for people to feel safe when they make critical changes. For example, schema migration, state migration, all those things. And lastly, you'll probably know running and operating on a Kafka cluster and all sorts of Flink clusters are not cheap and not easy. So there's still a lot of things to do to reduce the footprint and operational cost with running those systems. And at last, I want to talk about what we've learned so far. And I actually have many versions for this slide. So what you are seeing here is the first version I put, which I feel speaks for my heart the most. Samer talked about all the things why Flink is hard, why streaming is hard. When I work on this slide, I thought I did some calculation in my head about how our dev time actually spent. By far, we spend most of our time trying to convince Flink to do what user expects. All sorts of things, many engineers feel at some point that, they want to give up. We also spend a lot of time reading docs, and a fraction of the time to actually doing the integration. And also there's a long list of tasks you need to do to make this data platform operational. So I think the best way to summarize this is my interpretation of why streaming is hard. It takes a team to do all the things, and not every company has a team of Decodable or a team of Netflix to run the platform. That's all. So, and lastly, you can't call it a tech talk without, cat gifs. So this is mine. That basically shows the times when I want to give up on Flink.